Hello everyone and welcome to this 10-year retrospective on the IWOCL and SYCLcon conference. My name is Simon McIntosh-Smith and I'm a Professor of High Performance Computing at the University of Bristol, and I was one of the founders of this conference. Now let's cover some history first of all about where does the conference come from. Well, I was at a conference called Supercomputing in 2009. And I happened to see this demo, which was really impressive. There was a scientific application which had been ported to OpenCL, and it was running across several different kinds of CPU, several different GPUs, and even some bits of Roadrunner, which was the IBM cell processor, and it was running on all of those at once. It was one application, one instance, but using all of that different heterogeneous hardware all at once. And I'd never seen anything like that, and I was very impressed and very interested. And I got chatting to one of the people who developed the demo and was running the demo, and that turned out to be Ben Bergen, who was from the Los Alamos National Laboratory. And we got chatting about OpenCL, and I got very interested, and in my research I then started to look into OpenCL, and I started using it to explore research problems like performance portability, how you can develop codes that will run well across different ranges of hardware. And it turned out OpenCL was really good for this. So I got very much into OpenCL. And a few years later, I actually joined the OpenCL working group as part of Kronos. So I got involved in the standard itself. Now, over the next few years, myself and Ben was talking about there wasn't really a way for the OpenCL community to actually get together and meet. And we were both also involved in OpenMP, one of the other very popular parallel programming models in high performance computing. And that had a yearly conference where users and the vendors and the people developing the standard all got together to meet. And we liked that idea. And so we were thinking if we could do something different, something similar for OpenCL. And I went to visit Ben in Los Alamos in May 2012, actually on May the 8th. I'm recording this on May the 10th, 2022, so almost exactly 10 years to the day. And at that meeting, we decided we should try and create an annual OpenCL workshop. And that's really where the idea for IWOCL and SYCLcon was born. And this was actually before SYCL had been invented, so it was just OpenCL at the beginning. But several years later, as the investigations into what would become SYCL got going, we added sessions and workshops for that. And several years later again, when SYCL was created, we actually added things more specifically for SYCL, and now SYCL is starting to actually dominate a bit more as everything continues to evolve. So the first workshop after making this decision was organised in a bit of a rush, actually in about 2 months. So in 2013, initially we were planning to run in Los Alamos, but it was a bit too complicated to get people on site. So instead, David Bader at Georgia Tech offered to host us. And in just a couple of months, we pulled this together. And even with so little notice, we managed to get 40 attendees and about 11 speakers. And the whole thing went really well. So we thought, okay, this looks promising. We'll keep going. And since that first workshop in 2013, with 40 people, we've had a really successful run. So we started in Atlanta. The next year, we came to Bristol in the UK, where I'm based. 2015, we were hosted by Stanford in California. 2016, we came to Vienna in April. 2017, we went back to North America, went to Toronto. 2018, we actually came back to the UK for the second time, went to Oxford. 2019, we went back into North America and went to Boston. 2020, in May, we were planning to come to Munich in Germany. Events overtook us. We never quite made it to Munich, and we rescheduled once COVID kicked in for 2021 in May. Of course, we were all in our following waves by then, so it still hasn't happened. So we still haven't made it to Munich. We're hoping to come back to Europe for the next one. We've got a couple of options, so watch this space. But we're hoping that for 2023, we'll be back meeting together in person. And the workshops have been really well attended. We've generally had 80 to 90 delegates for each one, no matter where we went. I think Bristol was the biggest one we've done. We had up to 110 people one day in Bristol, and they've been really great workshops where we've had users and the standards developers and the vendors, i.e. the people who actually write the implementations, all getting together and chatting. And we found that really useful and really enriching for our community. So we're definitely planning on keeping going. Now, over the 10 years, we've developed some really interesting statistics. So we've had over 900 delegates in total so far. We've accepted 219 submissions over those 10 workshops, and between them, those have gathered nearly 33,000 downloads from the ACM digital library. So you can go and find the IWOCL proceedings for every year in the DL, and you can download them from there. Many of the slides and videos are also available from the IWOCL and SYCLcon website, so you can go and find them there too if you don't have access to the ACM digital library. So this is becoming a really great resource now. All of this interesting work in OpenCL and SYCL from the last 10 years, all captured, recorded and shared, and clearly it's garnered a lot of interest with 33,000 downloads so far and counting, and it's all continually going up. I check those stats every year. Now, over the 10 years, we've also had some really interesting things disclosed for the first time at the conference. So, for example, in several cases, we've had new versions of SYCL and OpenCL officially announced at the conference, which is really cool, and hopefully that will keep happening in the future too. There have been some really interesting tools which use OpenCL and SYCL that have been announced. One of the earliest was OCL Grind from James Price, which has been very useful and very popular. But we've had several profilers, a couple of debuggers, all sorts of other tools to help you develop SYCL and OpenCL code, all announced and described, and in some cases tutorials run at the conference too. We also see lots of uses of SYCL and OpenCL discussed at the conference. I've got just a few examples here, but there are many, many more. These are a few that stood out. So for example, a few years ago, there was an implementation of C++ AMP from Microsoft, which targeted OpenCL. We see lots of codes being ported to OpenCL or SYCL, including GROMACS, which has had both OpenCL and SYCL backends. Lots of different math libraries. There might be linear algebra libraries or FFT libraries and several others ported to SYCL and OpenCL too. Several different machine learning frameworks, all the really popular ones, having different backends generated for them. Boost.compute was ported. We've seen medical imaging codes. This year, 2022, we've got a really cool interactive ray tracing program, which is going to be discussed. We've got people targeting autonomous vehicles with SYCL now, drug discovery pipelines, even safety critical implementations of these standards all being disclosed and discussed at the conference, which is really fascinating. And another thing we all share when we get together is best practice. What's the best way of using these standards to target different processors, different CPUs, different GPUs, different kinds of accelerators, FPGAs, and we share what we learn amongst the community when we all get together. That's one of the really valuable things about the conference each year. So I've mentioned a few things there. Here's a few pictures from one of the cool tools that was shown off at IWOCL in 2015. This is when we were in Stanford in California. This is NanoSymbox. It's an interactive molecular dynamics program, and all the backend, all of the simulation, all the molecular dynamics calculations, all being accelerated in OpenCL. And even more cool, you can see the little picture of the laptop on the right here. In front of it is a leap motion hand tracking device, and you could wave your hand over that and interact with the simulation and poke it and prod it and move things around. And it was all OpenCL accelerated. That was really cool. That's from a few years ago. And from this year, I just mentioned the interactive real-time ray tracing. And this is something we happened to spot on Twitter and got in touch with the developer, Moritz, and he's going to be actually one of the speakers at IWOCL and SYCLcon this year in 2022. And he's been using OpenCL to do real-time ray tracing with a lattice Boltzmann simulation some of the most accurate models of raindrops and water droplets that have ever been performed, and it looks absolutely amazing. So do attend his talk, watch his talk if you get the chance, and it's all using OpenCL. Now, something I like to do each year when I open the conference is give an update on how many mentions the different parallel programming standards are receiving. And we use Google Scholar to do that, so a really simple, very straightforward methodology for gathering the data, and I report that each year. So I'm going to show you some stats we've just updated for OpenCL and for SYCL for 2022. So here's this graph. If you've seen me give this talk before, you'll have seen earlier versions of the graph. And just to explain the methodology, I use Google Scholar. I use very simple search terms like OpenCL or OpenMP. I think for CUDA, you've got to use CUDA and NVIDIA. I think for MPI, I use MPI and message passing interface. And just type those in. I refresh the data all together. So just in case Google's algorithms have been changing and they might find more or less papers from previous years, when I update the graph, I regenerate all the numbers. So there are no old numbers in here at all. I regenerated all of this the day I'm recording this, which is on May the 10th. So this is all brand new data. And I record stats for all the main parallel programming models that tend to get used or discussed in high performance computing, but some of these are of course very relevant in other spaces as well. So first of all, let's reveal the stats for 2021, because obviously last year those are still halfway through, so I always wait until the next year before we gather the stats from the previous year. And for 21, a lot of the same trends seem to be continuing. So CUDA seems to have been doing very well. Let's just get the laser pointer up. It's been doing very well. It was sort of flatlining a bit, and then in 2016, since 2016, it's been growing at about 7 or 8% every year. So 7 or 8% more papers mentioning CUDA since 2016. That's very interesting. So I dug into that last year actually to find out what was going on. And it turns out if you add the term AI to the CUDA and NVIDIA search term, you get still almost exactly the same number of papers. So the thing that really seems to have taken off is people starting to use GPUs for AI acceleration with things like TensorFlow and PyTorch and Caffe and all of these frameworks that have been ported to use GPUs and in particular CUDA. And that's been behind this consistent growth in papers mentioning CUDA ever since 2016. For all the other standards, they've mostly been slowly declining a little bit, or MPI is just starting to level off again, which is quite interesting to see. I'm not entirely sure why this is, because certainly for things like OpenMP and MPI, they are still being used more and more in high performance computing at least. So pretty much every HPC code uses MPI. So why would the number of papers that mention it be slowly declining? It could be that it's just becoming so accepted, so standard, so part of the defaults that nobody mentions it anymore. Like they might not mention their code happens to be written in Fortran or C or C++ or whatever. MPI is just part of the furniture, and so you don't mention it. There are certainly more and more codes using OpenMP as well. So again, it doesn't really explain why the number of papers that mention it continues to slowly decline. Who knows? So it would be interesting to dive into this data a bit more and find out what's going on. Now, there are some of the language down at the bottom here which are still in their sort of startup phase, still very small. We can't really see what's going on. So given that we're particularly interested in SYCL and OpenCL, I'm going to show just those lines on a new graph. It'll be exactly the same data, but so we can zoom in on them. So here we go. So this is exactly the same data from the previous graph, but just with OpenCL and SYCL. If we look at OpenCL, the high point was actually in 2017, when we had about 4,300 papers which mentioned OpenCL. And since then, we started to see the slow decline, and for 2021, there are about 3,000 papers which mentioned OpenCL. So still quite a lot of work going on that explicitly mentions the OpenCL standard. SYCL, well, the first time that was mentioned by anyone was in 2014, when it was being invented and dreamt up. And each year, the number of papers I mentioned, it's been slowly growing. Since about 2019, the rate of growth has accelerated. That's about when Intel started to talk about OneAPI and their DPC++, which is SYCL with some additions. And we're seeing a real acceleration since then. So 328 papers mentioning SYCL in 2021, last year, compared to just 23 in 2014. So that's quite a rapid growth rate now. I've also got some statistics where if you add together all of these numbers, what's the total number of papers which Google Scholar can find for mentioning all of the different standards? And this is what's in my third chart here. So this is the cumulative papers, the total number of papers found by Google Scholar which mention these different parallel programming models. And you can see CUDA's the biggest one with over 126,000 references in total. OpenMP, nearly 91,000, pretty good showing. Even more than MPI, which has about 76,000. OpenCL is the next largest, 44,000. That's about half of OpenMP. And given OpenMP is very ubiquitous in high-performance computing, that's actually a pretty good showing for OpenCL. Then all of the others still a lot smaller. So OpenACC, just over 9,000, 7,000 for Silk, nearly 5,000 for TBB, and SYCL now up over 1,000 in total. And remember, about a third of those were just last year. So we're really seeing some exponential growth in that, and it will be interesting to see what happens with the SYCL growth over the next few years. So all of that's really been about the last 10 years, how the conference started, where it's come from, what kinds of things it's seen, and some interesting statistics about OpenCL and SYCL and the other parallel programming models. So what do we think might happen over the next 10 years? Well, clearly we're not done yet. There are lots more advances still to come, lots more interesting things to happen. So I'm going to be very interested to see what really happens. Heterogeneous computing, which is really what motivates SYCL and OpenCL, is becoming ubiquitous. It has been for some time in embedded computing. Think about all the devices in our cell phones, in our tablets, other embedded devices. They've had CPUs, GPUs, DSPs, VLIW engines, video engines, AI engines for years. And programming all of those isn't going away. And this was really just the kind of thing that OpenCL and SYCL was dreamt up for. But even in high performance computing, we're seeing heterogeneous computing become more and more common. In the next couple of years, the next wave of really big supercomputers, which are called exascale systems, almost all of them will be CPU and GPU systems. So they're heterogeneous from the beginning. And things like SYCL and OpenCL are ideal for programming in or for targeting for backends for different sorts of code generation. We're expecting even more heterogeneity too. Lots of different kinds of accelerators, AI accelerators, video accelerators, you name it, people are dreaming it up. And they all need programming. And rather than reinventing the wheel every time, actually adapting SYCL, adapting OpenCL to support new accelerators is really what they were designed for. So they're becoming more and more relevant today. And this is even though I think OpenCL was being dreamt up in 2004, 2005. It's amazing how forward-looking that was and how relevant these heterogeneous parallel programming standards are today, even more so than they were when they were first dreamt up. And in particular, we're seeing SYCL's being really rapidly adopted and seeing growth in the adoption. We're seeing it being talked about a lot in AI. It's being mentioned more and more in autonomous vehicles. It's even now being considered for safety critical systems, which is absolutely fascinating. And that's today. And several of these application classes we wouldn't even have thought of 10 years ago when we were starting the conference. So who knows what new application areas will emerge over the next few years that we'll be able to talk about in another 10 years' time at the conference. So I hope you've enjoyed that little review of where we've come from, what cool things have happened at the conference, how the whole thing got started, and what we might see over the next 10 years. If you'd like a bit more information, of course, there's the main IWOCL and SYCLcon website, www.iwocl.org. You can go there. You can find pretty much all of the presentations and slides from previous years, all the way back to the first conference. So that's a really great resource. Obviously, the Chronos OpenCL website is the first place to go to find the latest version of the standards. Great resources in terms of lists of codes and implementations and tools, so do go and check that out. If you'd like to find out more about what my research group does with performance portability and how we've used OpenCL and SYCL, you can go to our webpage and find out what we're doing. If you'd like to get in touch with me, I put my email address there, happy to follow up. Or I'm also on Twitter, and I use that mostly to talk about high performance computing, so you can follow me there. So thank you for joining. It's been a real pleasure running the conference for the last 10 years. I'm so glad we've done it. I'm really looking forward to seeing what happens next. Looking forward to getting back with you all in person. Do keep attending the conference. Do come and talk with your peers. Share ideas about OpenCL and SYCL. Submit your own work. Get involved somehow. That's the main thing. It's a community, so please do get involved. And I really look forward to meeting you at a future conference.